Hi, I'm Mireya Prosapio, and I'll be talking about cellular respiration. Cellular respiration is an aerobic process, which means it uses oxygen and it occurs in the cells of heterotrophs. And what it does is the cell takes in a glucose and it turns it into 38 ATP. ATP being short for adenosine triphosphate, ATP powers our cells, in turn powers us. Now I know 38 ATP may not seem like a lot, but since all of our body cells perform this function millions of times per day, it gives us a new energy to move, breathe, and think. And it's a very long, complicated process, so I decided to represent it the best way I knew how, by making a live-action film. So please enjoy, starring me, Alexandra Dishman, and Olivia Gray. First, the cell takes in the glucose. My glucose has arrived. Time to take you to the cytoplasm. ATP, I need you! The cell uses 2 ATPs to break the glucose.
ATP! 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 Hang on, we gotta stretch.
Enzyme! Did somebody call for an enzyme?
Make these pretty.
Gotcha. Then the enzyme breaks down the glucose for net gain of... Here's what I made for you guys. 2 ATP, 2 NADH, and 2 pyruvates.
Looks great! I'll take these pyruvates straight to the mitochondria.
No pyruvates, only acetyl-CoA. Here, mix it with some oxygen.
Thanks.
By mixing the pyruvate with the oxygen, it turns it into acetyl-CoA. Then the process is repeated with the other pyruvate. And it moves on to the mitochondria for the Krebs cycle.
I'll take it from here.
First we add an acetyl-CoA. Then another acetyl-CoA. And then we drop some acid. Then you've got to mix it all up. And you just keep mixing and mixing and mixing. And then you get some more acid, except this time it's citric. Hey, I got a delivery for Dr. Krebs. Where is he?
Dr. Krebs!
I don't got all day, lady.
Dr. Krebs!
Hey, yo,
Delivery!
Krebs! Here's that citric acid you asked for. Agent Dr. Krebs, surgery number 1.
During the surgery of the cell, each citric acid gets turned into isocitrate, which is then converted to succinyl CoA, which is by the adding and removing of many substances and compounds,
Tweezers.
transformed, and you get a net gain of 2 ATP, 3 NADH, 1 FAD+, and some oxalic acid, which powers the Krebs cycle for another turnaround. And this is per citric acid, by the way. We're ready. Beautiful. 3 NADHs and 1 CO2. Nurse, exchange this CO2 for an FAD+, please.
Right away, doctor.
And get this oxalic acid back to the beginning of the Krebs cycle.
Yes, doctor.
NADHs and FAD+s give their electrons to power the... Hello, I heard you needed an NADH.
I do.
Here's an electron.
Thanks, I'll use it to power the electron transport. Bring in the proton!
Here you go. Here's the proton.
Thanks. Now I'm going to transport him across the mitochondrial matrix.
We have to go back.
If there are too many protons on one side to maintain homeostasis, the proton moves back across, thus powering the ATP synthase to be able to smash together an ADP and a phosphate to produce an ATP. Each NADH can power this process 3 times, so it just repeats over and over for each FAD+ and NADH, which in all produces a whopping 32 ATP. And that's cellular respiration for you. Thanks for watching.